Hello students, welcome to our discussion of Chapter 7, Interval Estimation, or the chapter that we learn how to build confidence intervals. Intervals being a range, confidence is assuming some level of accuracy. So this chapter continues on from the Chapter 6 material when we were talking about sampling. The big difference is in Chapter 6, we assumed we knew something about the population, as in the population average or the population proportion. In this chapter, as in real-life situations, we do not know a lot of data about the population, including the population mean. So that is why we have to take a sample. We take a sample in order to develop an educated guess about the population from the data that we collect in the sample. So in estimating the population average or proportion is enhanced when we involve or include a range or an interval. There are three different interval estimations that we will be doing in this chapter. An interval or range, you've probably seen this a few times in situations where for example, a poll will show, or results from a poll or survey will show that 55% of the population will vote for candidate A, 55% plus or minus 5%, for example. So that 5% is part of that estimated or educated guess. It's that interval. So go into the three types that we're going to develop. The first type is when we know the standard deviation from the population. So this value here is the population standard deviation. This value is known to us. So what we need in order to develop our first confidence interval or interval estimation is we need data from our sample. So we need this value here. This is the sample average. We also need, of course, this value, which we know this is the population standard deviation. We also need to know how many items or people were in the survey. So this is the sample size. And the task, or the part of the question, what we're trying to compete, is the confidence interval. We'll just abbreviate that CI. This is the confidence interval. The confidence interval generally is an assigned value given by the researcher or the sponsor for our survey. If we are tasked or assigned to do a survey for an organization or a group, they're going to say to develop an interval estimation, an educated guess based on a certain level of confidence. So when we put in those four values, we're going to develop our very first confidence interval formula, which is sample mean, x bar, plus or minus this z value, which is based on a symbol called alpha, and then the population standard deviation over the square root of n. So this part here, we know that this part here refers to the standard error. We learned about that in Chapter 6. The standard error is the population standard deviation over the square root of the sample size. This last part here is referred to as the margin of error. Some other textbooks may just refer to that as the error, sampling error. And part of that Z value, this is a special Z value we have, Z value based on that symbol there, alpha. And we will understand what we mean by that alpha symbol and how to find the correct Z value based on the level, the confidence interval, and the level of alpha. So that's our first confidence interval formula. There's 4 values we need. We from the data in the question, we plugged them in there, and we were able to develop that confidence interval. Before we go on, let's make sure we know how to find a Z value from the confidence interval. So this confidence interval here, let's go like this, basically leads to the Z value. So the question will always state a certain level of confidence. That level of confidence will always lead to a specific Z value. So how do we get a Z value from the level of confidence? So there are 4 commonly used intervals and Z values. So the confidence interval, 90%, 95%, 98%, 99%. Those are generally high levels of confidence, because what we don't want to do is or state after we have conducted a survey or done some research, we don't want to have a low level of confidence after all the work we've done, to state that we are only confident that our answer is correct at a 10% level or 20% level. We want to have a good A or A plus level of confidence. So this confidence level can also be written as a confidence coefficient. This is just basically the decimal number for the confidence level. So I'm going to show you how we can actually find the correct Z value. I'm going to use the 95% level. Okay, so let's we're going to draw out the normal distribution. Where's my, there it is. So we're going to draw this out. Oops. There's our bell curve. 95% interval. There's the average, which we don't know. But a 95% confidence interval states a certain range. 95% of all the values are going to be within a certain range. So that's 95%. So if this is 95%, how much is on each side? 95%, my pen keeps disappearing. So 95% as a decimal, let's do that, divided by 2 is 4750. So this part here, to write out there, 4750. And of course it's going to be the same on this half as well. This will be 4750. That interval always divides the level, or always divides that percentage by 2. So if you go into the normal distribution table, we have an area value of 0.475. 0.475 is right there at a Z value of 1.9, and we go up to the column 0.6, so 1.96. So a Z value that corresponds to 95% confidence interval is 1.96. If we did the same thing for 90%, we would have an area of 0.45 in both halves. 0.45 is going to be right in between those two values, 1.64 and 1.65. And, oops, we are always going to use we're going to use 1.64 as our Z value. Even though it's right in the middle, let's just we'll just stick with 1.64. That's not good. What's happened here? So 0.9, 0.95, 0.98, 0.99, 1.64, 1.96. The other ones we can find as well. Where's my chart? So 98% is going to be in this value here. 98% divided by 2 is 0.49. That's going to be 2.33. And 99% is 495, which is going to be right in between here. We're going to choose 2.58. So these are values we're going to use a lot. Anytime we're working with this type of confidence interval, when it asks for a 95% confidence interval, we're going to use a Z value 1.96. If it asks for 99% confidence interval, the Z value would be 2.58. So a couple notes about the interval estimation. As the interval widens, the precision of the estimate decreases. If the interval becomes too wide, the interval being that plus minus number, the estimate would have no practical value. And likewise, if it's too small, it may not be accurate. For example, if you were to ask me what I would predict, my educated guess would be for the temperature tomorrow, if I said it's going to be between minus 40 degrees Celsius to plus 40, I think I'm about almost 100% accurate. Right? Guaranteed the temperature is going to be somewhere between minus 40 and plus 40. This would be the same as saying 0 plus or minus 40. So as the interval widens, the precision of the estimate decreases. If this number is too big, compared to this value here, it doesn't have as much significance or accuracy. Even though I'm going to be 100% accurate, basically it has no practical value. Likewise, if I said it's going to be between minus 5 to plus 5 as a temperature tomorrow, really small interval, basically this is saying 0 plus or minus 5 degrees. But if I say that I think I'm only going to be 20% accurate, that has very little meaning as well. In this first case, I'm going to be almost 100% accurate. But how are you going to dress for the weather tomorrow between minus 40 and plus 40? You have no idea what to do. With this one, with a second example, you'd have an idea. Dress for, a little cold. But I'm only going to say I'm 20% accurate. So what we need is a high degree of accuracy, plus we need a small interval. That is probably the best of both worlds here. Another note for the interval estimation is this confidence interval, generally cited as this. We are 90% confident. Like in this first example here with the temperature, I was 100% confident. In the second example, I'm only stating 20% confident in my answer. Generally, a 90 confidence level indicates how strongly you believe you are correct based on your sampling data. A confidence interval also means that there's a 10% chance of error. So it's either one or the other, chance of error or being accurate. So a 2% chance of error would mean you're 98% confident in your answer. So this chance of error is denoted as alpha. Chance of error. We're going to come back in the next video working on some examples.